To mitigate the problem of course of dimensionality, there is a technique called dimensionality reduction. Inside dimensionality reduction, there are two techniques. The first one is feature selection and the next one is feature extraction. Under feature extraction, there is a technique called PCA, Principal Component Analysis, which is our main chapter. PCA is a technique which can transform a higher dimensional data to the lower dimensional data while keeping the essence of data. Some benefits using PCA are enhanced visualization, effective analysis, improved interpretation, data simplification, and faster execution of algorithm. Here in this picture, the original axis is x1, x2. PCA rotates the axis and tries to find out the new set of axes. One axis will be that one which cover maximum variance in data, that is C1, and another one is orthogonal to that axis, capturing the second highest variance, that is C2. These two new vectors are the best fit the distribution in the terms of variance, and data points are projected onto the new axis, typically onto PC1, while preserving as much of the information possible. When we reduce to lower dimension from the higher dimension, there is a disturbance in relationship between data points. So in order to maintain the relationship and that direction contains the most meaningful structure or patterns in the data, we need to choose the maximum variance. In this process, we remove the noise or redundant after removing the low variance. It's just like taking a photograph in a stadium. If you take it from the middle of the stands, you capture the full view of the ground, but if you take it from the side stand, the view is limited or flattened. So the middle gives you more meaningful information, just like PCA keeps the direction of maximum variance. This is a part 1 video in PCA. Hope you understand it. Thank you.